So today we are going to work on problem -33. As you can see here, we've got a minute hand here, an hour hand. We've got this hour hand is connected here and goes through to the hour hand here. The minute hand is actually goes through A, B, through a shaft and C, D. So what's happening here is the hour hand is spinning, and this gear is larger than this gear, and this gear is larger than this gear. So you're getting an increase from the hour hand. And if you think about it, it's written here, the ratio of the hour hand to the minute hand is 1 to 12. So every full rotation of the hour hand, you get 12 of the minute hand. So the problem here is, figure below shows a reverted clock train designed using 25-degree nominal pressure angles and 24 PD. 24 per inch, having between 12 and 150 teeth. Determine the number of teeth and the nominal center to center distance. If the center distance has a manufacturing tolerance of 6 thou, will the pressure angle and the backlash at the minute hand be at each extreme of the tolerance? So, going over to our whiteboard here, I've set the problem up here. So just a quick sketch over here. And again, NE, NC, NV, NA, hour hand, minute hand. Think about it, MV is always equal to omega out over omega in. In this case, the omega in is the hour hand, the omega out is the minute hand. I've just written here omega A equals minute hand, omega E equals hour hand. So MV equals omega out over omega in, omega minute hand over omega hour hand equals 12. So going back, R equals 12 equals product, second here, product driver over product driven, right? And so in this case, the driver is ratio is NE over NC. The negative is because we're going spur gear to spur gear. And then we got driver driven, NB over NA. And that's a negative. Negatives cross out. Okay, and this all equals 12. So really what we need to do now is break down 12 into two ratios, two numbers less than 12, two numbers less than 12 that multiply back to 12. Just to get factors to ratios from here to here and here to here. So I think we can only get a pretty common one. 12 equals 4 times 3. Okay, so we can call this R1 and this R2. Okay, so what is supercritical in a compound reverted gear train is we need NA plus NB to equal NC plus NE. And we're going to say that equals some value K. Now, we can say also that 4 is going to equal this here, NE over NC. And 3 is going to equal NB over NA. Okay, but what does K equal? Well, if you start to sub these in and around back into these equations here, you get this relationship that K is equal to 1 plus R1, 1 plus R2. Okay, so that's 1 plus 3, 1 plus 4 equals 20. So really this is your K min, and so we have to do multiples of K, and because of this relationship here, when we do multiples of K, we're always going to get integer values for all the gears, and they're always going to follow these ratios here. We really just need to cycle through K until we get to a minimum number of teeth, which I think in this case was 12. But before we do that, let's go back to these relationships here. Okay, so 4 equals NE over NC. So NE equals 4NC. And we're going to need this once we start cycling through these values of K. And then we've got 3 equals NB over NA. So NB equals 3NA. Okay, so let's just try the minimum K equals 20. And we're going to sub it back into this relationship here, right? So 20 equals NA plus NB, right? But what does NB is equal to 3NA, so this equals 4NA. Therefore, NA equals 5. And we know that's too small for spur gear. Just for completeness, let's go to the other side. 20 equals NC plus NE. Okay, and we go back to this relationship here. So this equals 5NC. So NC equals 4. So they're both too small. But our keen eye of observation should make you realize that if you multiply this by 3, this will go to 12, this will go to 15, and now we've reached our minimum pinion gear requirement. So 60 equals 4NA, NA equals 15, 60 equals 5NC, NC equals 12. How do we get back to the other gears? We have to go back to this relationship here. NA plus NB equals NC plus NE. NA plus NB equals 60. Okay, but what does NA equal? Equals 15, so NB equals 45. Going over here, just zooming back up for a second, NC plus NE. NC plus NE equals 60. NE equals 48. So with these two gear ratios, we will now get 1 rotation of the hour hand for 12 rotations around the clock, okay? So, and it will be reverted, okay? And remember, PD equals 24 per inch, okay? So we have NA equals 15. We know that PD equals N over D, or D equals N over PD, which equals 15 over 24 per inch. So this equals 0.625 inch. And we just continue on. NB equals 45. We know that PD equals N over D. We can skip to here. D equals 15 over 45. Sorry. No. Equals 45 over 24. 45 over 24. And that equals 1.875 inches. And C equals 12. I'm just going to zoom over to here. D equals 12 over 24 per inch. And again, this one up here is per inch. This gives you 0.5 inch. And again, this is diameter. And so NE equals 48. So D, let me fix that. So DE, DC, DB, and this is DA. Okay, so this equals 48 over 20. 24 per inch. This equals 2 inches. So now you have your diametric pitches here. So what are we going to do next? We are going to start to look at some center to center distances. Let me just scroll up here. I'm going to draw a line here. Okay. So your center to center nominal distances, call this CAB, equals dA over 2 plus dB over 2 equals 0.625 inch over 2 plus 1.875 inch over 2 equals 1.25 inches. So this is for CAB. Now, if you do your Cmin, as per the question, it's going to equal C minus 0.006 inch equals 1.244 inch, and C max, C plus 0.00 equals 1.2, what is that? 256. Nice and easy. Okay, so we have that now. Just scroll up here. Okay, now in order to calculate the backlash, actually your theta max, sorry, so your pressure angle max equals A cos RP cos phi over R max. Okay, so this equals A cos 1.25 cos 25 degrees over 1.256 inches equals 25 25.58, sorry. .58. So that's going to be our max, and our phi min is going to equal A cos RP cos phi over R min equals A cos 1.250 over 1.244 times cos 25 degrees. Get run off the page here. So let me go over here. Scroll up. So we get 24.401 degrees. So that's if they're super close together, the pressure angle drops. If they're at the far end of the tolerances, it's going to be 25.58 degrees. So you get a little increase in pressure angle. Now to calculate the backlash of one gear, let's just say theta B of A equals 43,200 delta C, which is the change in center to center distance, times the tan and the phi max over pi dA. So this equals 43,200, 0.006 inch, tan 25.58 degrees over pi 0.625 inch, and this equals 63.2 minutes arc. If you want to convert that to degrees, you would divide that by 60. So you'd have like 1.05 degrees or something. So anyway, just a reminder, this is the change, the tolerance on the nominal center to center distance. That's why it was 0.006 inch. Pi dA, so this theta backlash, it belongs to A. Okay, and it's 63.2 minutes of arc.